In this video, we're going to talk about the Fisher effect. And quite simply, the Fisher effect is just a way to express interest rates into some component parts. So let's start with solving for a nominal rate, or the actual rate. If you notice here, there are two sets of models. One, the Fisher effect itself, is only used for Treasury securities. So this top series of boxes, cells, is only for Treasury securities, and the one on the bottom can be used for anything. But primarily, we will want to have securities here that may have some form of a risk premium, if you will. So let's look at some interest, right? So let's assume that the real rate of return is 2%. Now, this number is typically given to us. It's very difficult to actually find this number published somewhere. But the inflation premium, let's assume it's 3.5%. What you'll notice is that the number isn't an additive function. It's actually, if you look at the formula up here, it is a calculation that assumes some time value of money growth. So if we come down below and you put in 3.5% as the inflation and 2.5 as the real rate, again, that's where we come out. It actually comes out to be 6%. So if we say we know the nominal rate's 5.57 and you're told inflation's 3.5, of course we're going to end up with that 2.0 number. So again, we can calculate, if we know the nominal rate and inflation, we can solve for real and vice versa. What the analysis that we can do is we can incorporate some taxes, right? So what if the corporate tax rate was 20%? Then your actual after-tax real rate would be 1.6%. And of course, there are some tax situations where we may want to incorporate that information. But let's go down below here where we're talking about a risky investment. So what if this risky investment had a 7% risk premium? If it had a 7% risk premium, we would expect its nominal rate to be around 13%. So plugging in 13%, the inflation premium 3.5, risk premium of 7. Again, we solve for our tax rate, or our real rate, of 2.5%. So again, there's not a lot going on with this model. The basic idea here is just to understand that interest rates have parts. The risk-free part up here, I didn't really mention that, but this nominal rate here, we would essentially refer to this as being the risk-free rate of return, because it only includes real rates and inflation. Down below, of course, we have a risk-oriented thing because we have risk premiums. So that is the basics of the Fisher effect and interest rates.